Welcome to Intellify. I'm Rasika Ramakrishna, and today we're going to be doing a few questions in the chapter Introduction to Trigonometry of Class 10. Exercise 8.2, question number 1. Evaluate the following. So this question has 5 subdivisions, and since we know the basic trigonometric ratios of 30, 60, 45, we have got to use these to evaluate these questions. Alright, so let's look at subdivision 1. Here we have to find sin 60 cos 30 plus sin 30 cos 60. Alright, so the obvious way of doing this question would be to substitute the values of sin 60, cos 30, sin 30 and cos 60, multiply them and add them up. But that's like, you could definitely do that, but every question also has a clever way of going about it, and I'm going to be talking about the clever way in this question. So here, let us suppose that A is equal to 60 degrees and B is equal to 30 degrees. Then the above can be written as sin A cos B plus cos A sin B. What is that? That is nothing but sin of A plus B. And A plus B is 90, so therefore we have it to be sin of 90, which you know is 1. So by doing this, we have just minimized the calculation that is required by us. So whenever you're presented with a question like this, the first thing that you've got to do is try and simplify it as much as possible so that the number of numerical calculations reduces. Alright, so let's look at subdivision 2. Here we have 2 tan square 45 plus cos square 30 minus sin square 60. Again, at this point, you can go ahead, substitute the values of tan 45, cos 30, sin 60 in the equation, add and subtract, and you'll arrive at the answer. Or we can do the following. So note that tan 45 is equal to 1. So keep that in your mind, alright? We also know that sine of 90 minus x is cos x. That is, sine and cos are complementary, right? So sine of 90 minus x is equal to cos x. So if you apply this particular relation between sine and cos in the above equation, we have cos 30 to be equal to sine of 90 minus 30, which is nothing but sine 60. Which implies that cos square 30 is now going to be equal to sin square 60. Therefore, we have cos square 30 minus sin square 60 to be equal to sin square 60 minus sin square 60, which is nothing but 0. So what we have essentially done is we have made this entire term 0. Therefore, the question reduces to 2 tan square 45, and you know tan 45 is 1, therefore the answer is just 2. So see, again we have reduced the amount of numerical calculations involved. Alright, so let's go look at subdivision 3. So we have cos 45 divided by secant 30 plus cosecant 30. Alright, so this question I wasn't able to figure out a clever way of going about it. I had to ultimately resort to like substituting the values. So that's what I'm going to be doing here. If you find out a clever way, please let me know. Alright, so now I've always found it difficult to remember what the values of secant 30 and cosecant 30 are. I mean, it's actually just the reciprocal of sine and cos, but I've somehow never been comfortable with them. So I always try to convert it back into cos and sine, right? So what I'm going to do here is I'm going to multiply the numerator and the denominator by sine 30 cos 30. So when I do this, what happens is we have cos 45 times sine 30 times cos 45 times sine 30 times cos 30 whole divided by sine 30 plus cos 30. So what happened here? Like the numerator obviously makes sense, but what happens to the denominator? How did secant 30 plus cosecant 30 become sine 30 plus cos 30? Well, when you multiply sine 30 cos 30 by the first term in the denominator, right? Secant 30 into sine 30 cos 30 is going to be sine 30 because secant 30 times cos 30 is 1. Therefore, the first term is sine 30. And similarly, if you multiply cosecant 30 by sine 30 cos 30, we are going to have cosecant 30 times sine 30 to be 1. Therefore, the second term is just cos 30. So this is the expression that we have. Now we know sine 30, cos 30 and cos 45, so that's all we've got to substitute in here. So yes, it is a pretty long expression. So let's look at it. So we will have cos 45 to be 1 by root 2. So in the numerator we'll have 1 by root 2 times 1 by 2 times root 3 by 2 whole divided by 1 plus root 3 whole divided by 2. Why is this? Because 1 by root 2 is cos 45, 1 by 2 is sine 30, root 3 by 2 is cos 30, and we have whole divided by 1 by 2 to be sine 30 and root 3 by 2 to be cos 30. So now all that is left is for us to simplify. So what we do is we have the numerator now to be root 3 by 4 root 2 and the denominator to be 1 plus root 3 by 2. Therefore, you can cancel out 4 root 2 and 2 and you will have root 3 by 2 root 2 in the numerator and the denominator will just be 1 plus root 3. So this is nothing but root 3 whole divided by 2 root 2 times 1 plus root 3. So it's always better to leave the answer in a better format. So what do I mean by better format? Having no irrational numbers in the denominator. So what we do is we go ahead and conjugate this. So we multiply by root 2 times 1 minus root 3. So we have root 3 into 1 minus root 3 into root 2 whole divided by 2 into 2 into 1 minus 3. I mean, this is basic calculation. I request you to work it out. So once you do this, you will be left with root 6 minus root 3 whole divided by 8. Okay, this is the third subdivision. I'm sorry that it had a lot of calculation. I wasn't able to cut it short in any way. Alright, so now let's move on to subdivision 4. Again, we are left with a question where I haven't found a way to reduce the calculation. I'm sorry about that. So let's look at this. So we have to find out sine 30 plus tan 45 minus cosecant 60 whole divided by secant 30 plus cos 60 plus cot 45. Alright, so here, I'm not even going to go ahead and simplify this expression. Let's just directly blindly substitute the values. So you know that sine 30 is 1 by 2, tan 45 is 1, cosecant 60 is 2 by root 3, secant 30 is 2 by root 3, cos 60 is 1 by 2, cot 45 is 1. So substitute all of these values in this expression. You will have 1 by 2 plus 1 minus 2 by root 3 whole divided by 2 by root 3 plus 1 by 2 plus 1. Alright, so it is of the form, if you notice, it is of the form a minus b by a plus b. So just I'm not going to be using that here, I'm just pointing that out. So you have root 3 plus 2 root 3 minus 4 whole divided by 2 root 3 whole divided by 4 plus root 3 plus 2 root 3 whole divided by 2 root 3. So now you can cancel out 2 root 3 and 2 root 3 and we go ahead, we obtain an expression, we rationalize it and we are left with 43 minus 24 root 3 whole divided by 11. I request you to go ahead and do the calculation. I'm not doing it step by step in this slide because it just gets a bit too messy when there are a lot of numbers. So I request you to pause this slide, work it out and compare with the answer in the slide. Alright, so let's move on to subdivision 5. Here we have 5 cos square 60 plus 4 secant square 30 minus tan square 45 whole divided by sin square 30 plus cos square 30. Now, the minute you have sine square, cos square and everything, bulb should just light up in your head because we can use our favorite trigonometric identities. So let's see what we can do. Now, we know that tan 45 is 1, right? And you also know that sine square x plus cos square x is equal to 1. This is your basic trigonometric identity. So what happens is this entire question now reduces to 5 cos square 60 plus 4 secant square 30 minus 1 because the denominator is 1, right? So now all that you've got to do is just substitute the value of cos 60 and secant 30 in the expression and you'll arrive at the answer. Thus, here as well, we have been able to successfully reduce the numerical calculation. So, we know that cos 60 is 1 by 2 and secant 30 is 2 by root 3. Therefore, substituting, we will have 5 by 4 plus 16 by 3 minus 1, which is nothing but 67 by 12.